This is JS Party, your weekly celebration of JavaScript and the web.
Good news, everyone!
We just dropped Dance Party, our third full-length album on changelog beats. Buy it on Bandcamp or stream it on Spotify, Apple Music, and the rest. Link in the show notes.
Enjoy the drop.
Thank you to our partners at fly.io. Launch your app close to your users. Find out how at fly.io. Okay, hey, it is party time, y'all.
What's up, friends? This episode of JS Party is brought to you by our friends over at Vercel, and I'm here with Lee Robinson, VP of Product. Lee, I know you know the tagline for Vercel, develop, preview, ship, which has been perfect, but now there's more after the ship process. You have to worry about security, observability, and other parts of just running an application in production. What's the story there? What's beyond shipping for Vercel?
Yeah, when I'm building my side projects or when I'm building my personal site, it often looks like develop, preview, ship. I try out some new features. I try out a new framework. I'm just hacking around with something on the weekends. Everything looks good. Great. I ship it. I'm done. But as we talk to more customers, as we've grown as a company, as we've added new products, there's a lot more to the product portfolio of Vercel nowadays to help pass that experience. So when you're building larger, more complex products, and when you're working with larger teams, you want to have more features, more functionality. So tangibly, what that means is features like our Vercel Firewall product to help you be safe and to have that layer of security. Features like our logging and observability tools so that you can understand and observe your application in production, understand if there's errors, understand if things are running smoothly, and get alerted on those. And also then really an expansion of our integration suite as well too, because you might already be using a tool like a Datadog, or you might already be using a tool at the end of this software development lifecycle that you want to integrate with to continue to scale and secure and observe your application. And we try to fit into those as well too. So we've kind of continued to bolster and improve the last mile of delivery.
That sounds amazing. So who's using the Vercel platform like that? Can you share some names?
Yeah, I'm thrilled that we have some amazing customers like Under Armour, Nintendo, Washington Post, Zapier, who use Vercel's fronting cloud to not only help scale their infrastructure, scale their business and their product, but then also enable their team of many developers to be able to iterate on their products really quickly and take their ideas and build the next great thing.
Very cool. With zero configuration for over 35 frameworks, Vercel's frontend cloud makes it easy for any team to deploy their apps. Today, you can get started with a 14-day free trial of Vercel Pro or get a customized enterprise demo from their team. Visit vercel.com/changelogpod to get started. That's vercel.com/changelogpod.
Hello, JS Party listeners. Welcome to yet another week with us. We're very excited about today's show and today's guests. We're going to be talking about React server components and kind of deconstructing them with Dan Abramov, who's here to kind of help us bust some myths, set some truths, do some deep dives, set some facts. I've already been fact-checked like 7 times just in preparation for this show. Dan's already set the record straight, so I'm like excited to continue to be fact-checked. With us to kind of ride along with us for this ride today is Eric Clemmons, my friend who I invited to essentially play the zealots role, right? Because I think I've been outside of this React community for a little bit now, and I'm coming at this from the skeptic's perspective, and Eric is like very deep within, and he's a zealot, and he's like a lover of all the things, and he's been playing around with RCs and he loves them. And so I'm really excited to kind of have his voice on the show. And then of course you have Dan, who's been, part of the core team for many years and generally been educating the community for many years around best practices and how to use React and all of that jazz. So I'm super excited about today's discussion. So with that said, let's get started with introductions. So welcome, Dan. Can you tell us a little bit about yourself, even though I feel like you don't really need an introduction.
Yeah, first, thank you so much for inviting me. I'm super happy to be here. So I started using React in 2014, I think. And after that, I joined the React team in 2015. And I've been on the React team for about 8 years, I think. I'm currently on kind of a break because I joined Blue Sky, which is a company that uses React and React Native. So I'm actually learning React Native and like learning how to use it. And I'm really kind of in the product development mindset as a user of React now. So I haven't actually been very involved with the team, and I kind of speak in personal capacity on this show. So yeah.
Dan, it feels like the React Core team is a little bit like Hotel California, where you can never quite leave, because I know you're not officially part of it, but based on the internet, you would never know. You would never know, right? Because you're talking about it and you're just like, you're in all the things.
I feel like it's actually the other way around, because like officially I'm still on the team, but actually like I haven't showed up to meetings for a while just because like I'm too like overloaded trying to learn React Native. So I do want to get back to it. So I'm on a bit of a sabbatical, I guess.
So you're talking about React Native. I want to know, when is Blue Sky going to have a web client?
It does. Yeah, so there is a bsky.app. I think that's... I might be wrong, but I think that's the current year. We have like 3 different domains.
Okay.
I keep forgetting which one is which.
Okay, I have to check out the web client. That's great. And so Eric, again, welcome back to the show. Can you give our listeners a little bit of, besides you're a mega DX nerd, tell us a little bit about yourself.
Yeah. Thanks for having me, of course. But it's interesting. It's like I've been in the web space for such a long time. People are kind of like touting their tenure in web. But what I think is really interesting is just like the evolution that's continually happening. And one of which was like whenever React dropped, I think like the 0.12 days. The company I was at, we were focused on just building kind of like web forms. And as long as we got the job done, they didn't really care like how we built things. So we got to kind of, cut ourselves on the bleeding edge a little bit. But the thing was like React really was a hero from the very beginning, going from like an Angular app and PHP apps. Like we went to server-side React back in the day, probably a little too soon, and had to figure out like async data fetching and serializing data and stuff. But the result of it was millions of dollars of actual like conversions that happened as a result of like faster rendering, response times, progressive enhancement basically was what we kind of like shot for there. And so like React was the thing that kind of made us successful for, I think, 6 years of just continually to build off of. And so I wouldn't be here if it weren't for React, actually, I'd say.
Yeah. And you have some pretty popular libraries too. One of them being click to component, which I really love, and I feel like more people need to know about that and use it. But it's a component that, like, do you want to tell people about it?
Yeah, I mean, everything's born out of a DX need, right? And I wish I could just be funded full time to take all the paper cuts that developers deal with and like make them all 10x engineers. But yeah, the long and short of it is that most of the time when you're doing web development, you see what's on the page, you say that's either right or that's not right, and you just need to kind of go to the source code. And going through like the dev tools won't get you straight to the source code. But click to component is a wrapper. There's a Chrome extension that I think has actually like surpassed it in terms of functionality and multi-framework support. I don't have the name for it offhand, but I think it's probably like the way to go for individuals who just want to look at the page, go straight to the source, fix it, and have like a faster feedback loop. But that's actually like the long and short of it, is that like being able to focus on the like what you're trying to do and get all of the annoying friction and steps out of the way in between you and just getting your job done. And actually, I think RSCs like play into that narrative pretty well.
That's awesome, and excited to dig in. So before we dig into RSCs, I kind of want to do a couple things. Like one, I want us to tell, like, I want to hear from both of you on like, what is your React love story? Because, the three of us didn't found it, right? So like in theory, we saw it and we were like, ooh, right? So what's your React love story? And then I want to get into kind of the evolution of React, and that will kind of take us into like RSCs and where we are today. I'll kind of start first with my React love story. So for me, I think I came into React from the Angular 1X world and Backbone and CanJS and Knockout, like so many different things, jQuery, right? Like, it's a whole smorgasbord of things, including like Rails, PHP, a lot of things. And I think for me, what just clicked was that, it just like, it just made sense, like looking at a React component and the way things were structured. The fact that everything was just JavaScript for me was the big like aha, right? Because I didn't have to learn any additional syntax. Like if I wanted to loop or map or do whatever, like it was just JavaScript. Sure, there was a couple of things you had to learn around, like what is the syntax around JSX, right? But for the most part, everything just felt very intuitive. And I think for me, it was just, like starting to kind of become a lead at that point. Like it was just seeing the accelerator, like seeing how much of an accelerator it was for teams, quickly creating components, being able to kind of compose them easily, being able to kind of organize their code in a better way. It was just kind of like, it went from, you were able to kind of go from zero to hero very quickly. And I think that was really exciting. Of course, it came along with some pretty big shifts around, like, you had to use a compiler for the first time, in the JavaScript world, and, and you're getting things from NPM, and, that was new, right? But for the most part, huge accelerator. And I think, was a huge fan of React. I think for me, where React started to kind of, where I shifted into a skeptic was specifically around, when I started to see frameworks like Preact come along and, have very similar API with lower bundle size and better performance. And I was like, you know what, I would really like more of a focus on performance. The other kind of skeptic, like my skepticism kind of grew with, how the suspense and concurrency and some of the other kind of shifts in the API, where I was like, you know what, I really want to just focus more on performance. Like, let's just fix that problem. And then I kind of moved into different spaces, and that's just kind of where I dropped off. But for the most part, like that's my love story with React. And I think it obviously really shifted the ecosystem forward as well in terms of design. So Dan and Eric, eager to hear from you both.
I think it's actually interesting you mentioned that you're interested in performance, but then the things that kind of shifted your attention were like, these are features for performance. So there is an interesting irony there.
It is ironic. I think it was just that the API, it wasn't just, it was around the same time that I know suspense was kind of there to kind of improve perf to some degree. But the point is, like, the API around hooks, I think the design also really bothered me specifically. Like, I thought that, like, it just wasn't intuitive. It just kind of, like, everything in React was intuitive until, like, hooks came along for me. Like, this is my personal opinion. I think that's kind of where, like, for me, like, the seed of skepticism was, like, planted, and, like, it just never fully gone away. So, but I'm hopeful. Like, again, like, I'm here to hopefully change my opinion on things. So let's, I'm coming to this conversation with an open mind, right? So back to you.
Sure. Yeah. So for me, I think the first time I looked at the React, I thought that just looks silly. But then I was pretty new to web development at the time. So before that, I was doing mostly desktop development with C#, .NET, and a little bit of mobile with iOS, and also C# using what's now called Xamarin. I don't know if that's a thing anymore, but that's what I was using. And then we started using Angular 1.x for a little bit, built some UIs with it. And at some point, React came out. I kind of dismissed it originally. I didn't get it. And then my colleague, like a few months later, my colleague sent the link to React again. He was like, no, like, check it out. Like, there is something to this. And so I tried to, like, at the time I was actually, so I was working on an app where you could post different kind of like multimedia posts with like images, galleries, text, and a bunch of stuff. And I was at the time working on the like button. So I needed to add, like a like button. You can press like, it shows you liked this, or you and like Andrew, you liked this, or like you and like 3 people like this. So it has to like show different things depending on, what the data is. And then like when you press it, it can kind of push it over into like one of these different states. And I tried, at the time we were using Backbone, and, like you had to write your initial template for, the initial data, but then you had to listen to events. So like, did I press the button and then change, the template dynamically to the final state? And then with React, just like the first time I tried it, I realized, I can just write an if statement. So like, if nobody liked this, then return this. If one person liked this, return this. And React handles the transitions between these states. So I can just describe the user interface as a function of of state, or like kind of like as a frame in a movie, and there's only the current frame. You never think about time. And so this was my first React component, just a like button. And then we started trying it in a few more places, and it kind of just ate our app from inside out, because, you know, it started like somewhere deep, and then we gradually started using more and more React as we kind of climbed higher. And even though like, I think like that was before, you know, people were complaining about JavaScript fatigue and like all that stuff, like we were excited because, you know, everything used to be so bad. Like it was just very hard to build dynamic UIs, and we were rewriting our product in React at the same time as shipping features, and actually we were faster while doing the rewriting, just because React enabled us to make everything so dynamic. So that's kind of how I think that was that moment for me.
You knew what you're doing mentioning JavaScript fatigue there, Dan. I see what you did.
I was like attacking Eric. Yeah, Eric had a famous viral blog post from back in the day titled exactly that.
Yeah, that was such an interesting thing, because I think that blog post actually kind of got us talking a little more one-on-one, because that was, you know, right before the Create React app abstractions. And like those days, Babel preset EMV wasn't a thing. So, and that did strike a chord with, I think, like the React community, but I don't think actually because of React. I think it was because of everything else around React in retrospect. But it's so funny. We had such interesting, like, and similar love stories. Like we kind of got into it around the same time, like on the ground floor. And I think like that's a bit of our honeymoon period, where like a lot of people who got in there early, they see React today, and that's not the React that like they fell in love with like 10 years ago, it seems, you know, that they got comfortable.
That's me.
Yeah. It's like, it was successful. It got the job done, but like, it's not like how you do React anymore. It's like, you've changed, but I haven't. But yeah, it was an incremental thing for us too. Like we had a PHP based business. The page response times were like around 800 milliseconds or something like that. And whenever we had the issue of just complex form logic, and we want to make sure that when we submit forms and validate data, that the logic in PHP backend was the same as the front end, that we're trying to improve for good experience. And so like, if only we could use JavaScript everywhere. And once we did that, the response times went to like 200 milliseconds. And that was like our first attempt at using React, and already got that much better. And in an e-commerce, you improve like, you know, response times and conversions go up. And then we got it down to like to 40 milliseconds. And the business is just like, whatever you're doing, step on the gas, keep it up. And so like, we just went headstrong into everything else around React, the whole JavaScript ecosystem. Like we got deep into Webpack 2 at the time released. We got async bundles to improve like encode splitting to improve performance even more. And then looking outwards, because of React success, it made us look at other things like, well, what else could we do that this community is doing? And led us to continuous deployment. And we're deploying dozens of times a day for a business that was deploying, you know, once a week or once every 2 weeks, and, you know, had a multi-hour deployment process. And so like, I would say like React was kind of like that first hit of the JavaScript drug that got us successful, gave us that high, and then we kept going with everything else in the ecosystem. And we had no idea, you know, people talk about like a new framework every day, but there's a new solution so often that's solving some problem unique to maybe your case, but not, you know, some that don't apply to you. And you get to just have a buffet of stuff that's potentially going to make your business better. And we were able to ride that wave for years, until like I left the business like 6 years or something later after the initial adoption. So yeah, I mean, I think I'm doing Python today. You know, Dan, you're talking about like learning React Native, and like I've had to learn Python. Thank you, ChatGPT and Copilot, for teaching me Python syntax. But it makes me miss, you know, the velocity I had of being able to have end-to-end JavaScript, React, and that locality of behavior.
Yeah, so well said, Eric. And yeah, like this is like a pretty good segue into kind of, you know, the evolution of React, because, you know, you mentioned that person from 10 years ago that was using React, like maybe coming into it today would be like, this feels very different, right? And I think I started at 0.12, 0.13, like that's kind of when we kind of started using React in production. And, you know, we had a very innovative leader on the engineering side who was like very bullish on good tech and wasn't afraid of kind of being on the bleeding edge. And like, you know, even though that was very early, like they were totally willing to to kind of go all in on React. And so, Dan, can you talk us through kind of React from 10 years ago to like where we are today, right? Going from these components that were often used on the client, right? Like specifically, like they weren't always SPAs, but like for the most part, kind of going into kind of the server-side rendered revolution, kind of fueled by, I think, frameworks like Next.js. And then, to kind of where we are today, ushering in, this kind of data fetching as a first-class world with React Server components.
So let me try to kind of recap So we're talking now about kind of paradigms of where we run the code, right? So not so much like the syntax, but more just how we use compute and resources. And one way I like to think about it is like in general in app development, but specifically in web development. Like in web development, you always have to think about at least two computers, right? So there's the computer, the device that the user has. So it could be their phone or it could be like a desktop device. It's like they're probably using the browser to open your app. And then, of course, there has to be some other computer that actually sends the information to the user, right? So there has to be some kind of a server, that either sends HTML or JavaScript or both, or some JSON. And so the question is just like, how do we use the resources of those? Of course, there could be, another computer earlier that maybe does the build, or, when you deploy, like somehow the code has to get from the developer's machine to that server. So there's also some kind of a step of deployment. And so the question is like, how do we split, the resources between these different computers, and what do we actually make them do? And so at the time when we just started using React, there were already different paradigms of how to split these resources. So one very popular paradigm was kind of traditional server rendering, unrelated, like when I say server rendering, I mean like PHP or Rails, where you mostly write your UI logic as HTML-ish templates, which, you have some kind of control flow things, like you have like loops, conditions, you have some kind of includes maybe, so you can put one template into another template. And that is happening completely on the server side. So you're able to directly access any resources that are on the server. So for example, you can read from the database, you can read from the file system. Of course, you can also, build a bunch of services and just talk to them by HTTP on your server. So that is something you can always do, but you're also not forced to do that if it doesn't make sense for some task. And so that was kind of the paradigm. But then within this paradigm, it's pretty hard to build like very dynamic, very instantly responsive user interfaces, because if your UI logic is completely on the server, then you have to talk to the server to get, any kind of visual update. And for some cases it's fine, but in like something like drag and drop interactions or gestures, or just like typing into an input and immediately, like for example, like filtering a list without going to the server, stuff like this, like you can't really express it in this paradigm very nicely. And then that is where we started shifting more work to the client, where maybe you'd have some jQuery plugins that enhance the HTML you return from your server templates, but that let you add some instant interactivity where that the screen can update without a network round trip. And so I think that was kind of like, you could already kind of go extreme in either direction, like already at the time, right? Because like you could have everything that's like server rendered with some like PHP and maybe like a few jQuery plugins to just like enhance it in a few places. But there were also this approach of single page apps was starting to gain traction, where you actually wouldn't send any HTML at all. And instead you would only send JavaScript, and then the JavaScript would be kind of creating that, initial HTML and managing the DOM nodes completely on the client. And so the benefit of that paradigm is that you have the guarantee that you can always make an interaction instant. So you have this guarantee that, you're not going to get locked out of being able to like show immediate feedback, because all the code is on the client. And so all the code that's necessary to produce the UI is already available. But then the downside of that is, of course, you have to download a lot more code kind of upfront. You don't show anything to the user while the code is loading. So it's kind of bad for performance. And it also complicates the mental model quite a bit, because now you've had to move all the routing to the client. You have to have some kind of cache-in for any data. Like, you have to think about kind of state management, like how long does this data live? In which case does it invalidate? Like, when is it okay to throw away? So it's kind of like painful, like in a different way. But when React came out, like these were kind of two popular paradigms. And so React was used in both ways. So for example, at Facebook, React was used more kind of in this like jQuery scenario where we'd initially use React, for example, like in the facebook.com web app, React was used only like in the comments section of each post. So the entire page was server rendered with PHP, but the comments section was actually rendered with React, and React kind of took over, so that this particular piece can be instantly interactive. Whereas in the community, I think some people adopted React like that, whereas like other people already had single page apps with something like Backbone or Angular, and so they already had all their code on the client, and so they started kind of replacing, not like initially replacing just small parts of it with React, but gradually, because there is no, it's not a server-based paradigm, you can kind of go all the way up and replace it with React like completely. And so I think in 2015 or so, React Router got fairly popular. So that was, I think, like first kind of major or like popular solution for routing fully on the client without, going to the server to decide what the route should show, fully client-side paradigm. And especially with, when Create React App came out, it kind of solidified this as, this seems to be, because like if everyone is running, like all the server solutions are very different, so you can't really like release any tool chain that like addresses them all, because it has to be custom anyway. Whereas if you're moving everything to the client, like that's easier to kind of agree on that here's like the baseline of how these features could work. And so Create React App kind of made this approach even more popular because it became easier to start with. You just, you run it and you get yourself an SPA.
I think you just answered a long question that I had, Dan, which is, why when React was first released into the public, like not necessarily internally, why wasn't there a router, And I think it's obviously because Facebook wasn't using it that way, right? They were using it to kind of hydrate or like supercharge parts of their web app, right? But like essentially that's not how they were using it.
Yeah, absolutely. So that is a part of the reasons. Like Facebook generally doesn't release something that they're not themselves using, and Create React App was an exception to that, because Create React App was not used at Facebook at all. But there was so much like frustration in the community about, we have this like 5 different tools that need to talk to each other, and they're very like kind of finicky to configure. And the idea with Create React App was like, it actually came out of like we were supposed to write a documentation page about setting up React, and it was just like, it was embarrassing to write, because it was like set up these like 5 different tools and then like make this tool like talk to this. It was very confusing, and also like why it didn't make sense that like everybody has to, every time each of these tools updates, like everybody has to look for updated instructions. So we're like, okay, let's just make a thing that kind of hides them behind something that's like behind an abstraction level. Like the abstraction level kind of went up. Yeah, and so that's how SPAs with React kind of became the norm, I think. But we already know like there are at least 2 or 3 problems there, like in this paradigm. So one problem is that we don't send any HTML on the initial load. And that's just, I think like when you don't know how to do it, or like when there is no nice way to do it that's maintainable, like I could kind of see it or understand it. But I think like we figured out how to do it. Like we figured out good ways to do it that doesn't require you to write your code 2 times. And for example, with something like jQuery, if you have like a jQuery combo box or like a dropdown or something, you can't really produce HTML from it, because the whole paradigm of jQuery is you operate on the DOM nodes. So any UI logic is expressed as you take a DOM node, you like change its attributes and so on. So you can't really extract, what is the initial render, like what is the initial version of this UI. You can't like run some jQuery code and figure that out on the server. But the thing that like was interesting about React was that because it's a function of state, you could call that function with the initial state. You get a tree, and then you can turn that tree into HTML. And so we had this like client-side app, like it's like conceptually client-side, it's written for the client. But we figured out that actually you can run the client-side app on the server once per request, produce HTML from it, and then send the actual client-side program, to the client so that it can boot up on top of that HTML. And so that was what's usually called SSR in the React paradigm. It's just this ability to generate an initial kind of pre-rendered snapshot of the client-side app, client tree, but on the server. So that's why it's called like server-side rendering, but it's really client rendering, like pre-rendering the client on the server. And there's like another variation of that like Next.js became like one of the popular kind of ways to, like one of the first frameworks to do SSR in React, although again, like the ability to do SSR is provided by React itself, right? It's just React DOM/server render to string. That was like the initial API. And then Next.js was kind of like create React app, but that was designed around this idea that actually we already know how to pre-render the client tree on the server, but we might as well do that. And then you have this, the other innovation it had was file system-based routing. So the idea was, well, in traditional PHP app, if you go to, pages/about, you only, it has some script tags, right? Like your about.php or whatever, it sends some script tags to the browser. So you send different script tags, like you have the ability to send a different client code depending on what page you're on. And so in that sense, the SPA paradigm is a regression because now we send the code for all possible pages, even though the user has actually requested a specific one. So that's not really efficient. And so the other thing that Next.js did from the beginning was that, unlike Create React App, where everything is sent as a single bundle, or like you use bundle splitting, but you can only do this like once the code has downloaded, in Next.js there was like the components you used from the page would get sent as script tags, in script tags from those pages. So code splitting was built in.
I was going to ask a question that I think you've like somewhat answered. So like the whole SSR, like remember like that function render to string, right? So ultimately like it wasn't the most performant. And I'm curious, like, was Facebook using that internally, right? Because like and if it was, then like why wasn't the performance like more of a focus, in subsequent releases, just kind of like getting that down?
Yeah. So I think there's like a misconception in general when people talk about React performance, because a lot of this comes from kind of marketing, like JS frameworks, like benchmarks or something like this that runs like a tight loop with like one component level or like 3 component levels. And that shows you it's kind of like looking at the microscope at like one tiny part of what actually executes. Whereas like in any real app, most of the time is spent in executing the user's code, like the code that you write, your components. And so the problem with render to string, like you're absolutely right that there were performance issues with it. But I think there's like a misconception that maybe these performance issues are just because like React was slow, so let's just make React faster. That's not really how it works, because it's just a while loop. Like it doesn't really do much. It's like a while loop that calls your components and concatenates them into a string. So there isn't really much to optimize there. The thing you could optimize is actually inefficient it's like about how do you sequence different things that the app needs to do. So as an example, like if you want your initial HTML to contain some data, there's a question of like, when do you kick off, these data fetches? So like, do they happen during rendering somehow, or do they happen ahead of time? And typically, because in React, there was no support for asynchronous components, or like there were no built-in asynchronous primitives, you always had to do this. If you wanted these data fetch, results to be in the initial HTML, you had to do them ahead of time. So you had to do like await, fetch or whatever, and then render your tree, which means you're not really using the computing resources of the machine, because you could have started doing something, but you're waiting for all the data to be available before you started. So it's a sequencing problem. And that is why like Facebook couldn't use, even as Facebook started adopting So Facebook started rewriting their main app fully in React in 2017, maybe. I'm not sure. 2018, like around that time. And because render to string was synchronous, like that was just a non-starter, because for Facebook, it's just the fact that, a page is composed of many different things. Some of the things are going to be slower than others, and we can't wait for everything to be ready before we, emit all the HTML. What we want to do is just trim it. So we want to start rendering the components. Then if some of them are not ready, we want to send some kind of load-in placeholders or just hold the stream for a little bit. And then when they're ready, we kind of continue and we just emit more and more things in the stream. And so, answering your question of like why React didn't focus on that, like React actually did focus exactly on this, and but from this other perspective. So not from the perspective of like trying to make React faster, because you just run into limitations of, there's only so much you can do with the while loop. But from the perspective of like, how do we schedule the code written by the users, of React, so that we can stream as much as possible before we, until we're blocked on some data that we just can't render something because we're waiting. And then we emit some kind of placeholders. And so this is the suspense API, where you can say like, I want to send this like shimmer or a glimmer or like a loading state. And then React will automatically send the rest later. And so that was streaming server rendering. That's something that React 18 came out with, and that Facebook had. That was like, without that, Facebook could not have even moved to using React on the entire page.
So this is really interesting to hear, because it just, it kind of takes me back and triggers some nostalgia, but also it's just like the data. I'm going to use like those numbers. So before PHP application 800 milliseconds. React application, 200 milliseconds. And then finally, we landed around like 40 milliseconds. That was a win. Could it be sub-millisecond today? Yeah, probably. But at the time, so it's all the same data fetching existed. So React was just the implementation detail of how were we going to make, I think that UI as a function of state has done so much like heavy lifting in terms of like selling React, and also like, composing components and writing, markdown with event handlers and everything kind of like together. It clicked, versus the progressive enhancement days of jQuery, like you mentioned, where you're primarily mutating DOM nodes and you don't even know what it's, even supposed to look like out of state 20 of 400. So whenever we got to 200 milliseconds, the first, actually, I think open source library I wrote was called like React Resolver, and it was using decorators at the time, which are experimental. And I'm actually had to remove from some old code at my job. Actually, we had legacy decorators still in the code, and I'm like, whoops, gotta nix that. But anyway, it effectively just wrapped components with, hey, fetch this API, and then you can keep rendering. And that's what got us to 200 milliseconds. We were rendering the full tree synchronously whenever we hit basically that React Resolver decorator. It's like, okay, fetch the data. There's going to be waterfalling, but we'll parallelize anything at the same time. And then we're going to re-render the tree until we hit it again. So like it was very inefficient, but it was still 4 times faster than whenever we try to do it like with PHP and render the templates and everything. Finally, we actually said, well, hang on, do we need to fetch all this data right here? And we took out some of the server-side rendering. And we ended up rendering just basically the initial shell with like a suspense-like spinner, loader in the middle of the page. And then the rest of it, we fetched on the client. And that's where the server was spending 40 milliseconds. But in terms of the user experience, it felt faster, because now it was 5 times faster to actually see the code, in front, on your screen. And so whenever I see React today, it feels like all of the Wild West paradigms and like, hacks that I had to put together to get the experience I want of really taking all of the data needs that never went away, but I was just kind of moving on from the right to the left, and then like, threading them through different parts of the UIs to yield the best UX. It just seems that like kind of over time with the introduction of suspense, that now it's like, okay, now there's first class primitives for me to use to get the behavior that I had to hack around myself for. So I would you say like that's kind of accurate? Like these, like what React is, the React today compared to the React 10 years ago is, to me, honing in on web problems. The data fetching was always kind of there. The the latency across networks and, network boundaries and API calls was always there. Talking to the database was always there. Caching was always there. Where do you cache and how do you invalidate? That stuff was always there. What I see for React in the most recent RSC discourse is we have 10 years of learning of people building, going from counter examples, which I personally don't find very helpful for illustrating, the value of frameworks anymore. So I wish button counters disappeared, unless it's PartyKit showing a demo. That's totally fine. The PartyKit demos, with server side or socket RSCs was pretty cool. But it just seems that React is able to say we can better serve this need with these better, abstractions or paradigms or whatever. And also it's it went from, React doesn't have a router. React isn't, you bring your own router, that sort of thing. As part of that learning exercise and building more and more ambitious applications on React, it seems that it became necessary for React to say, well, we got to work with bundler integration because you have to bundle an app today. If you did a single page app, it made your React code base integrated. Everything was co-located together. It was all component driven. It was instant from the UI. But it also ended up yielding terrible dev experiences too, and terrible user experiences because you started shipping 10 megabyte bundles as well. So I see the pendulum moving back and forth, and as a result, new abstractions just had to arise as part of that learning.
Yeah, I think so. You jumped a little bit ahead to server components, which we do have to get to this topic at some point. Of course.
We actually, hold on, Dan. Before we respond to that, I did want to kind of ask about the uncanny valley, right? The problem where we send over this kind of serialized HTML that's it looks interactable, but it's really, there's still JavaScript that needs to be parsed, before that page is interactable. And so that was also another issue that was became a thing with server-side rendered, a lot of server-side rendered applications. This wasn't specifically just a React problem, right? And so I'm just curious also if you could kind of shed some light there and how RSC potentially helps that.
Yeah, so I do want to get to RSCs just a little bit later, because this is more of a kind of history of, I like Eric's framing of we've learned for 10 years and we actually took a step back. And I think this is the point that's maybe not coming across, is that RSCs are kind of taking a step back from everything we've seen for the past 20 years and then kind of rethinking it, how could it work? How do we apply all these lessons while having a component model? And so I do want, so far it kind of feels we keep stacking up more and more, complicated things to address issues. But I do feel RSCs are also a step back in okay, how do we make it simple again? But before we get to that, so answering your specific question about, you're absolutely right. There's this problem of, okay, if we do have a lot of JavaScript to send, and we send HTML, but then it looks there's a button, you click it, nothing happens. So this is something that was also a problem for Facebook.com. And this is we kind of had a pretty long period of rethinking SSR and how SSR and this process of, sending a pre-rendered app and then sending the code for the app and then having the code to the app kind of attached to that HTML. So this is a process that we changed how it works in React. And the key innovation there was also inspired by our old school PHP setup. So there's this thing called BigPipe, which is a technology Facebook used, from 2010 or so. I think it was described in some blog post. It's this idea of, instead of sending all of the code at once, and even all HTML at once, you kind of send it in chunks. Because in HTML, traditionally, even if you stream it, so even if you send it as it becomes available, streaming in HTML is depth first. So you kind of have to stream each child after, you kind of have to drill down into the tree as you're sending it. But then if you have this problem where, for example, maybe you have, you serve a profile, and you have, the profile feed, you have the about section, you have the photos section, you have events section, something like this. And let's say the photos section is a little slow. So in the traditional HTML model, if it's slow, you're stuck on the server trying to send the HTML for it, and you don't have the data yet, you can't really skip over it. You're already in the HTML, you're kind of stuck there. And then this idea that like Facebook used in its PHP setup was to have an abstraction that lets you break down the page into independent sections that were called pagelets. And each pagelet could have its own like data dependencies, CSS dependencies, JavaScript dependencies. And the idea was to send it kind of breadth first. So you kind of get the chrome of the page with this shimmers for pagelets. Then like each pagelet can kind of stream in later, and it sends a little bit of glue code to just put it in the right place in the DOM. And so it kind of keeps revealing like with nested, like a train schedule, like more data arrived. Let's reveal a bit more like CSS arrived. We're ready to reveal this piece. And so this is something we integrated with React, and this is what Suspense is. I mean, Suspense in general is just an API that lets you say, this part of the tree, if it's not ready, show a glimmer, or like show a placeholder, or like show like a spinner, or whatever you specify. So it's a very kind of designery concept. It's how designers think about loading states. Like they don't think about promises or data fetch, and they just think about, here's a part of the screen, if it's not ready, show this fallback. Here's like the fallback I designed. And it's such a powerful concept because if it's declarative, it means you can build technology that understands what to do if something's not ready. And so like one thing you can use it for is this kind of streaming, where if on the server you encounter that like a piece is not ready, you send the fallback, and then you kind of load, you send the rest of it later. So this is kind of how React solves this problem with, like previously in traditional kind of server-side rendering solutions, you had to download all JavaScript just for it to start kind of hydrating. By hydrating, I mean this process of attaching the event handlers and becoming interactive. And so it kind of became like it had to become interactive in a single pass when all the code and all the data and all HTML has already been downloaded. But with Suspense, and you don't need to do anything special for it. It's just it's just how it works. If you specify the Suspense placeholders around pieces of content that are maybe slower, React actually hydrates it in chunks as well. So it's able to kind of hydrate the first pass where all the things like outside, photos and about and the feed become interactive. Then like as it gets a bit more code is downloaded, like now it has the code for the feed composer. So maybe you can like posts. And all of this, of course, happens like, within like something like 10 seconds. So it's not about, something super long running, but it's just like chunked up so that it's able to do that in small parts.
Yeah, that makes perfect sense. I also feel like that's kind of a little bit of like the Astro Islands like paradigm as well, like, where breaking things up into smaller chunks allows for kind of faster processing and, and better kind of prioritization of like what should load first, et cetera, et cetera. And, just browsers are pretty fast at parsing JavaScript in general these days. But, by chunking, you're able to kind of like shorten that time.
What's up, friends? I'm here with Conrad Hoffmeyer from PowerSync. PowerSync is the sync layer that enables an offline-first architecture to make your application real-time and reactive. Conrad, why is offline-first, local-first a big deal right now for developers?
We're really excited about local first as a movement, and we think it's going to become the default architecture for a very large number of apps that are going to be built going forward, just because it has really big benefits for both developers and end users. So taking a step back, just looking at what local first is. So it's an architecture where your app code works directly with a client-side embedded database, which then automatically syncs with a backend database in the background. That's compared to cloud-first apps where they mostly use a cloud data store via APIs. That has some really big benefits for developers and end users, having a local database and syncing with the cloud in the background. The biggest benefit for end users is that everything in the app feels instant because the app is working with a local database and you don't have to do round trips to the cloud. There's no loading spinners. Everything can just load instantly. It also means that the apps can be always available for the most part, regardless of connection. So even if the user goes offline, the app is always available. So like you said, if you have a momentary lapse in connectivity, if you're driving through a tunnel or if you're on the subway or if you're out in a rural area, you don't have latency and the app can just keep on working and loading data out of the local database.
So this move to an offline first architecture, what are the biggest benefits for developers?
The biggest benefit for developers is that it really simplifies state management. So state management is a headache for most apps. Developers typically work with some kind of state management library or framework. There's a lot of kind of finicky aspects to it. But with local first, the global state is simply stored in the local database, like a SQLite database. And that really simplifies the app code. It keeps your logic really simple and functional because your UI basically just reflects the content of the database. So it just makes everything a lot simpler. And then there's other benefits for developers too. Since you're working with data and logic locally, your backend becomes simpler. You have to do less API development on the backend. You can shift a lot of stuff to the front end, a lot of working with the data, manipulating the data and logic. And they also reduce your backend compute load and compute cost and your dependency on the backend in general. So it kind of takes the backend API off the critical path for the user using the application.
I like it. Very cool. What's your goal with PowerSync?
Our goal with PowerSync is to be framework agnostic and eventually even backend database agnostic, but we already support Flutter, React Native, JavaScript for web apps. Kotlin SDK is right around the corner. Our web SDK plays well with any JavaScript framework, including Next.js. Yeah, the goal is to be framework agnostic, and we will also be becoming increasingly backend database agnostic, so supporting additional backend databases, not just Postgres, but also Microsoft SQL Server, MySQL, etc. But there's a ton of applications that can communicate with the cloud asynchronously, where you can primarily work with a local database. And therefore, we think for the majority of apps, local first will become sort of the default architecture.
Okay, the next step is to head to powersync.com/changelog to learn more. Take your application offline first for free with PowerSync using their free tier. No credit card required. Again, powersync.com/changelog.
So all of this like fun around server-side rendering, okay, we have suspense. And so where do we get to this like RSC, how do React server components kind of come into fruition, right? Like what problem are they? I mean, I think we've kind of maybe even set the problem up pretty clearly, but I'd love to hear in your words, like what problem are we solving by bringing this kind of data fetching as kind of first class as a React primitive?
Yeah, so this is an interesting question because like, I think we have this background of like, here are things we've learned over the 10 years. For example, like one thing is like, you want to be able to start doing the matchup work without waiting for like everything to finish, like every previous stage to finish. So you want things to be kind of like chunky. You want to be able to like send a part of the code and have like the rest load later and so on without waiting. So you have like all these constraints of like what a good solution should look like. Another thing we learned is client-server waterfalls are bad. So you never really want a solution that forces you like, you go to the server, you get something back, you start rendering it, you're like, oh, I need to go to the server again, you know, like use effect, fetch and use effect. You like go to the server again, get something, you continue rendering, and it's like, oh, we need to go to the server again. It's just, you know, it doesn't, it's not efficient, but it's how a lot of kind of single page apps end up working. So we have all these constraints on what a good solution should look like. But actually, I like to think about React Server Components as, you know, not some kind of optimization or, you know, not just some kind of like way to make things faster. I kind of like to think about it as combining, you know, two mental models that have been pretty successful in the past. Like one is the traditional kind of request response mental model that we liked in PHP or Rails, where, you know, you're in the programming environment that has the data, so you can easily kind of query it, you can access it directly. And then the other paradigm is traditional React paradigm, where you're on the client, so you can instantly respond to interactions. And so React Server Components kind of tries to answer the question, what if you tied these two paradigms kind of together and you could create components that span both of these worlds? And as a concrete example, you know, it doesn't even necessarily require a server that runs JavaScript, because, you know, another kind of thing we learned over those 10 years is if you have some code that's able to serve a request, you can now also run that code during the build in some cases. So that's how static generators like, you know, Gatsby or Jekyll in the Ruby ecosystem work, is that you can have a server, but you you have a tool that calls the server during the build with predefined file folders or slugs, like for a block, and then you have the final product. And then you can only, it's enough to have a static server that just serves those files, so you don't actually need to run a server. And so React Server components are kind of similar in that, you could run a server with them, but you could also run them during the build if you're building something like a blog where you know ahead of time, like what kind of routes you have, and you just kind of pre-render them. But I think the main thing that's like important there is, for example, if I'm making a blog with React, right? Like, let's say I want to display a searchable list of my blog posts. And let's say, for example, that I don't actually have like too many blog posts. So I don't need to have like run a server that like executes the search. I really want it to be like a local thing where like I have a text box, I start typing into it and it filters the kind of like an SPA, right? Like I just start typing and I already have the data. It just shows the filtered posts. So the thing is, in React, I really want to be able to take things on the screen and make them into components. So just like a designer thinks about the user interface, like the designer doesn't think about server or client or like any of that jazz, or like the designer doesn't care where the data is coming from. They just say like, here's an article, here's a comment box, or here's like a searchable list. But the problem is that in traditional React, a searchable list that I described is kind of an impossible component because it depends on data from two different computers. Because it depends on the current state of the input. So it depends on like what you've typed. And like I, as an author, I just can't know that, I can't know this ahead of time. This is a computation on your machine. But then it also depends on the list of blog posts, which is something that your computer can't know because that data is mine. Like I have to pass it to you somehow. And so if you had to write a component like this in traditional client-side React, it would have to accept all blog posts as props. So it would not be self-contained because it would need that data to be coming from somewhere. So it's not really, I can't really have like a block, searchable block list component and like put it in two places because I would have to somehow plumb the data into it. And so with server components, the idea is that, well, what if, the data could be coming from a parent component that just ran ahead of time on my computer. So the component execution kind of becomes split where I can have like a component that runs on my computer that reads, the list of blog posts, and it renders the component that will later run on your computer that does the actual filtering. And it's just a shift in mental model from when where is the data coming from? Because in traditional client-side SPAs and this model, you kind of think of the data comes somewhere from the side. You kind of think of like, I write a component, it does some kind of a fetch, and like the data it like waits for something. But with server components, the mental model is kind of like, well, the data is just coming from a parent component that already ran like on the server or during the build. So it's like the data always comes from above.
Yeah, so I think this is where I get a little confused, Dan. So you're saying that like the data comes from a parent component that calculates it ahead of time, but like how do you calculate it ahead of time? I mean, if it's dependent on input that you get from a user, I think that's a little.
Yeah, so you can imagine, for example, if I'm talking about like a searchable blog posts component, right? What I do is I split it in two. So there is kind of like a boundary between them. In React, server components it's called use client directive. But you can kind of think of it as being similar as a script tag. So there's the stuff inside the script tab, that's the component that will run on your computer. And then there's stuff outside of it that's like the stuff that runs ahead of time. So maybe like one way to think of it is like you can imagine if this is PHP and jQuery instead of, React on both sides, then you have the PHP side that, does like enumerates the folders in my blog. And then, it would render a script tag with my jQuery code and pass some data to it. So this is kind of similar, except you don't think in script tags at all. It's just, you kind of like write a component that does await fs.readDir to read the files on the server or during the build. And then you just say, return your other component that is able to do the filtering and has use state in it. And you just pass blog posts equals blog posts to that component. And then in the child component, you just have all the blog posts as props. So you can filter them and you can use state there. So you kind of like think about it in isolation. Here is like the first pass and here is the second pass. Yeah, I'm not sure if this like is too abstract, but
yeah, no, that's definitely not too abstract, and I think it's sinking in a little bit more. But yeah, go ahead, Eric, and we can kind of come back.
So being on like this React journey for so long, that was the synchronous nature of React was the thing that I kind of thought that like initially I understood it. Whenever you have in my mind it was like, okay, if UI is a function of state, then you probably want this thing to be straight in, straight out sort of deal. Introducing promises, as we learned from like the stately team, it's like, okay, now you have like this whole complex state machine that you're going to deal with, like with error states and everything. But whenever I saw an async component within a wait for like data fetching, it clicked for me because that's always how I expected it to kind of work. And it just took, basically years of like workarounds and basically wrapper components to effectively accomplish like what I was already trying to accomplish, like within my code. I mentioned React like resolver before, but then like what kind of ended up happening is like we'd have a use effect doing a fetch, and that component effectively turned into like the spinner loader component on the server whenever we rendered and spat it out, and then like it finally actually did the fetch on the client. So like to me, seeing like async, was the async component usage, was that something that that started working because of RRSCs, or is it something that became supported because of suspense? Like what architecture allowed there to be an asynchronous component? Because it still requires, because of the async nature, does there need to be a suspense boundary above anything that's an async component within a wait on the inside?
Yeah, so we currently only, in the future we might support some version of async components on the client too, but currently it's only supported in the in-server components. And I think like a big reason for that is avoiding performance food guns, because again, what you expect on the client in general is that you expect instant interactions, right? So you expect that when you change some state, we're immediately able to respond with some kind of feedback to the user. And so if you could put arbitrary like async components into the tree, then we can't really show a new consistent tree until they have executed. So that might introduce delays. And so the way the server components paradigm solves this problem is that all the async stuff actually happens ahead of time, like on the server or during the build. So you never have this issue where you change some state and then it gets stuck because it's waiting for something on the client. It's more like a request response model where all the server components output is already pre-computed by the time you get the page. From your kind of client perspective, they don't even exist. Like you only kind of see the props that they gave you. So you just have props from somewhere. You don't really kind of know where they're coming from. And then if you do a navigation, like that's where we do a refetch. And on navigation, we can load the output of server components again for like the next page or for like a refresh of the data. But again, all the async stuff kind of executes on the server, and then when you get it on the client, it kind of feels synchronous. So you can, you just read them from props. You don't really like think about like waiting for something.
Got it. Yeah, because on the server, you don't have that consistency problem. It's really only a single state that ever gets rendered. And that state comes from, I guess, instead of like a function of state equals like the UI, is it like a function of the request?
Yeah.
Maybe a way of thinking about it on the server?
It's kind of like a function of URL. And you could also think of it like as a function of data in the sense of just like you kind of read state on the client, like sure it's coming from React, but kind of conceptually just like read something that's, some memory on your computer that's state, whereas like some memory on the server that's kind of data. It's probably like something from the database or something from a file read, or even, result of like fetching from microservices, but they don't have to be exposed to the client computer. So it's just like UI is a function of data. And it's kind of like UI is a function of both. It's just executed in two stages. Like first, all the stuff that depends on the data executes on the server. That output gets sent to the client, and that's your normal React tree that works as usual.
Got it.
Yeah, and that's for me, that's where it clicks, Dan. Like, so essentially there's a remote call that's executed from the client that's like, go prefetch, go pre-calculate these things, right? Like go render out this part of the tree. And then, based on these inputs, and then send that back. And that computation is done in the server. And so I think that's the piece that I needed to hear, because, you mentioned like the stuff happens ahead of time, but it's really, when you say ahead of time, it's really ahead of time of the page, like fully rendering, right? Like,
I mean, like, yeah, it's just when you're like in the client first mentality, you kind of think of the client code as the beginning of the world.
Right.
It's kind of like, this is where my program starts. So you kind of like think, oh, like if I need data, I need to like call for it. But the thing is, like, this client program was already sent by another computer.
From the server, yeah.
Yeah, so that all the data stuff could have just happened there and be inlined into the stuff that gets sent to you. And that's how traditional kind of server-side rendering worked. Is like, if jQuery plugins needed some data, PHP could put that data into the page.
Right.
And so it kind of extends this idea that another way to think about it is it's kind of like sending JSX over the wire almost, except of course for first load you also want to send HTML, but it's kind of like if you had one API endpoint and the only thing that API endpoint could do is return, like, give me a JSX for the next page. And that's what it kind of responds with.
Yeah, and that's like really smart, because we're able to kind of do more with less, and we're able to do more earlier and leverage this like hidden server, right? Like that we don't really think about a bit more efficiently.
Definitely that, and also it lets you think in components. So it kind of breaks down this, like I have. Because usually you think of these as like two processes that are completely unrelated, like prepare all the data, prepare, like, deal with some state. But like in this like filterable list example, it's like specific data and specific state I needed to render a UI. And so I can kind of compose these components together. And now I can have this filterable list component that I can just like render in different parts, on different pages if needed. With different props, like, I just use it as a React component, but it's able to kind of access both the data, from the server, and the client part is able to access the state and that kind of stuff. So it's about full stack components that are composable.
You said something I thought was actually interesting, is that, like, paraphrasing, but like to the effect of, when we see a component, we see like a client component as like the start of it, or start of the world or whatever. And RSCs, I think, clicked for me because, it was always starting on the server. Static generation to me was like an optimization of like, I'll just perform that first request on the server and cache it and write it out. So like it always kind of clicked. I think a lot of React developers came in at the single page app time. And where it was all, I'm working on an app today that's like, I think the code base goes back 6+ years with like React Router 3. And so whenever we see that, do you think that that client first sort of experience history or mentality is a reason why there was like a knee-jerk reaction to, await DB SQL call or something like, why are you doing a SQL call in my code? I can't remember how long ago this happened, but like the fact that a React component could access the database within the component seemed to like spark some FUD. Do you think it was that kind of like client first mentality that allowed that sort of mentality to take place?
Yeah, I think it's definitely, part of it is like, sure, like using SQL inside a component on a conference slide, like, yeah, you're gonna make some people mad. That's just, it is kind of a troll move a little bit, but
you got the point across, right?
Right. But I think like sometimes it feels like maybe it gets the wrong point across, because people have an expectation when they see React code that it executes on the client. And so if you see React code during like a SQL query, you kind of think of like, is it calling SQL from a client? A lot of people, for example, like one of the misconceptions about RSC is that people think that it mixes client-side and server-side code in the same file. So that actually never happens. That's like something we don't allow, specifically because it's very hard to understand. Like that's something that current solutions do sometimes, like Next Pages router mixes server and client code in the same file. Remix mixes server and client code. The current version of Remix does that. But like in the future, with like eventual, hopefully like adopting RSC, we'd like to move where we never do that. So like in the RSC model, we never mix server and client code in the same file. But I think, yeah, the knee-jerk reaction is partially just because when you see something shaped like a React component, you think that it's something that has to execute on the client. But I think it's kind of like, like in the Matrix movie, where like Neo realizes that actually like the world is not real, it's created from another world. I think that's kind of like a similar, if you're like client-centric, like you write a component, but like, what do you think sent this component to the browser? Like there was a piece of code that did that, whether it's like a static file server or like an actual server that like emitted a script tag. Like there was some code that's responsible for your component getting there. So what if you had full control over that code? And what if you had a component model for that code as well, so that you could write components that kind of span both worlds and that are able to, pass data and then you can reuse them.
Yeah. So Dan, like what's really interesting, like for me about better digesting this kind of paradigm is like there's this shift away from like, what we would traditionally do to like make a request to go get some JSON and then like, take that and like rehydrate our apps, right? And you see this also with HTMX, right? With where they do this transclusion, right? They kind of skip that whole JSON serialization steps, so, but this very much feels like that, but like with React's primitives, right? So like, how do we now just like skip a whole bunch of steps and just make data fetching first class, build it into like the component and like give you a way to do that in a more efficient way? Like that's kind of what's clicking for me.
Yeah. I think philosophically, it's kind of funny that HTMX is, it's like, what if HTMX had a component model, right? Like HTMX doesn't really have a component model because on the server, you're expected to write templates that emit HTMX stuff. And then like HTMX has like a bunch of attributes that kind of specify some client-side behavior. So what if like you took, HTMX attributes, they're kind of like Angular 1.x directives. So like, what if we just turned that into React components and that would be the client side? And then what if we took the templates that emit the HTMX?
Yeah.
And what if we turned that into React components and that would be server components?
Yeah.
And so now you have kind of React on both sides. And it always, like the mental model is just, it executes in two stages. The server stuff executes first, that produces the JSX that gets sent to the client, and that's where state updates happen. And so state updates can always be like instant because this is the part of the code that only depends on state. And then the components that also depend on data, that is the stuff where, you do like a router refetch or server action, or like you do like one of those things that are kind of triggering, a refresh. And then that sends, that re-executes the components on the server that are necessary, that sends JSX. And because it's not sending HTML, it can be turned into HTML. That's what we do for first render. But for kind of next navigations, we actually don't. We just send the tree itself. And so this, for example, enables you to have animations between these trees, or it's kind of like just receiving new props. Like you're like, well, I guess like I got new props. I can, React re-renders it without destroying the DOM. So it's just a way to get props from the server.
Okay. So if we're looking at like the network, right? So if I have the network tab open, like what am I seeing here using RSCs?
This is very interesting. I think it's fascinating how it works. So I'll first talk about the case of navigations after the first load, because first load is special. Because for first load, we have to send HTML as well. So that kind of like, it has this like a program inside a program. Like we want to have the snapshot that the browser can display immediately, because of course the browser doesn't understand like React's custom format. But then for navigations, we don't need HTML because we don't want to replace, inner HTML and like lose all state. So we actually just send the React tree. So conceptually, you can think of it as like what you're going to see is kind of like a JSX tree, but in a different format. So one way to think about it is, so if you take a tag, right, like a div, you can write it as HTML. So you can write it, angle brackets div, or you can write it as JSON. So you could say like a type, colon, string, div, like it has to be a string, right? Like we need to tell what kind of element it is. And then if it has some attributes, like we could say like type div, props, like class name, something, right? So that's like a JSON object. And so you can think of a React component tree, or like actually like as a DOM tree. Like you could think of it as sending it as these like turning it into JSON, right? So you could say like type div props children a something, and that would be like an anchor tag. So you can kind of think of HTML as being expressible in like JSON format. Then the next thing is sometimes, you also want interactivity and like client-side code. So you need to you need the client to know where to get that code, right? Kind of like in HTML, this is solved with a script tag. So in HTML, you just have like a script tag with some file name, and then the browser will download it. And like in our format, it's kind of embedded into the tags. So you could have, type div, which is a built-in one, or you could have like type counter. Except wait, like counter, like it's not enough to send a string, right? Because the browser doesn't know what the counter is. So really we send an object that says source, the URL to the script. So it's the same as script source. It's kind of like where to download that code from, and the module ID. So like counter is maybe module number 20 in main.js, or like chunk something.js. And so this just tells React, oh, here's how I download this code for the counter. And this is why like React Server Component needs a bundler integration, because we need a way to ask, hey, bundler, go fetch the chunk and give us the counter component from it. And so then React can use it. So you really kind of see this tree that's, kind of like HTML tree, but it's in JSON. And it has built-in elements like strings, and it has kind of references. We call it a client reference, which is really just an object that says, here's where to download the code for this component. Here's which chunk it's in. And then the last part that's kind of important is we don't send it as JSON, kind of as a normal depth-first JSON object, because that has the same problem I described earlier of like you have to, drill down. So instead of, it's kind of like JSON with holes, where sometimes you just have like a hole that says like hole number 0, like hole number 1. And then the protocol actually sends them line by line. So there's like, here's the hole number 0, here's the hole number 1. And so this lets us like progressively show that tree. And then the parts that are not ready, the suspense boundaries, you can have your own suspense boundaries that show fallbacks. And so this lets us stream, even if some data fetches are slow, this lets us send as much of the tree as possible, as early as possible, and keep kind of streaming in the rest.
Wow. So we basically solved the problem that Meta had, or Facebook had, right? Facebook.com had many years ago.
Yeah.
This is fascinating. And so, this is like a good time to kind of ask about the bundler topic, because I think one of the things that I keep reading about is that, this, React Server Components allow you to send up like less JavaScript to the client, right? Like, which I think is like fantastic. And because we're doing some of that compute off the user's machine, right? So we can kind of keep the JavaScript that's needed for that off the user's machine, right? Like, duh. Can you talk about some of that a little bit? That's like such a fantastic side benefit. Like, I don't know if that was like the intended goal, but like if that was just like a happy side effect, but I'm here for it either way. So
yeah, I think that's, there's like a theme here is like, I think like a React early on, it's built on a very simple idea, right? Like UI is a function of state. And here it's kind of like React is like UI is like a function of data and state that's partially applied over the network. I know that's like a super computer science way to say it, but like it's just like a program that executes in 2 steps, and the intermediate result of the first step is being sent. And because conceptually this is a very simple idea, and you could think of like PHP plus jQuery app as also, it's a program for 2 computers, but these 2 parts can't really like talk to each other in some well-specified way. And we say, no, there is a way to talk to them. One of them passes props to the other one. That is how they communicate. And so I think like you do get a lot of happy accidents from this model just by kind of the way it works. Like you said, yes, like it lets you send less code to the client because a bunch of logic you could run it ahead of time. And this is maybe where like a comparison to something like Astro is very appropriate, where if you think of like Astro templates, they kind of serve the same role as server components, like they execute ahead of time. So you can, like on my blog, I have this funny feature where I show the color of my blog posts. It's kind of like a gradient. So like from older to, from newer to older, but the gradient is adjusted by how recently I posted. So you can see here are the recent posts because they're like in the brightest color. And then the old posts are like kind of closer to the end of the spectrum. And And so I use a library that does color interpolation for that. But because I do this while generating the posts, I just do it on the server, and I pass the interpolated colors as props to my components. So I don't need to actually, but then if I wanted to, like I could just move one line into the client component, and now this library would be on the client, and now it would be able to respond to interact. Like if this was like an interactive color picker, then it would make sense to run it on the client. It's kind of this ability to like shift things back and forth that is really interesting. And the other thing that I think is maybe less well known, but is actually also pretty valuable, is not only we can send, some code now we don't need to send to the client at all because it just, runs ahead of time or like on the server. But also for the code that we do have to send to the client, we don't have like one giant bundle that's like always the same. And we don't even need to, like I mentioned earlier, like Next.js router kind of did the split by the route. So like you send the code that's used by a route. But with server components, a bundler is able, this is kind of more theoretical, like current generation bundlers don't take advantage of this very well. But in principle, you only need to really send the code that's actually used, that's necessary for the current request or like for a current page. Because this is another thing that like at Facebook was very important, that if you send the code for the feed, you don't want to send like the client code for all possible story types because there's like maybe like 100 of them. Or if you're doing like a markdown, if you're doing like a blog with client-side examples in different pages, you don't want to send like all of the client code whenever you visit the blog. Like you actually want to send the code that's used by the current page. And so because server components execute on the server and they return client components, and then, the script tags are only sent for the chunks that are actually used by the output. So that's like kind of like automatic like code splitting. And you don't even like need to write, like dynamic imports or anything. It's just, it kind of falls out of the paradigm.
Oh, okay. Wow. Yeah. That is so cool. What a really cool side effect. Yeah, it makes sense. Like, because a React server component could also have client components nested within it. And like, we don't really need to even we don't need that chunk until we get, until we're at this step of the interaction, right? So that's awesome. And so, I mean, like, obviously this is going to be a silly question now because I think we've really beat this topic to death, right? But you do not need a quote unquote server to use React server components, right? Like this is like a pretty big misconception. And this is because we're able to use the server that's used to kind of literally serve your app, right?
So I think there's kind of like different ways to look at it. There's like using React server components to the full, where you like take full advantage of the paradigm. And in this case, it does make sense, some things are just easier to do when you actually run a server that can run some JavaScript code. But there's kind of like, you can take away different things from the paradigm because really, like, I think maybe the biggest misconception, I think, is people think of React server components as like somehow changing React, or like, it's like because you get dropped into a different world by default. It's like you kind of, when you write like an RSC app, you get dropped into the server world first, which is kind of like an Astro template, but it looks like your familiar client world. And you're like, why can't I use an event handler here? Like, I expect to write a counter component, I can do it. And like, it forces you to actually like, you need to step into the client world to do that stuff. But when you start on the server, like you can do like file system reads or database and stuff like this. But again, it's kind of like, RSC is an extension of the React programming model. So it's kind of like, it's not like a replacement. It's just, here's the client React that we knew, and here is like a complement to it. Here's like the other side that you can add, and you choose how much of that side you want to add, and you also choose at which point it runs. Because if it runs, if you want to have a completely static file server like with SPAs, then of course you can't run any JavaScript code at request time, but you could run some at the build time. And so this is kind of generalizing what static site generators have been doing, except with React paradigm. So, this is what lets me write a blog that does fs.read, and then I specify generate, the server component output for this list of pages, because these are like pages on my blog. And then I get like the build product is a bunch of JS, a bunch of CSS, and a bunch of HTML files, and just a bunch of this pre-computed like JSON-y things that the client can download on navigation so that it doesn't blow away the state of the page. It's kind of like JSON essentially, right? But it represents React trees. So there's something you can totally do. But then, if you want to take advantage, and like you can kind of think of every SPA as almost like it's kind of like a valid RSC app with a single server component that just returns, the existing app. So it kind of like falls into the model as well. Of course, there's like nuances about routing, like you can't really take advantage of it without the router being on the server side because you don't know what page is being requested.
To clarify, you said there needs to be like a bundler integration is required to kind of make all this magic happen and work, right? So like what bundlers are supporting this and like today, and then what's on the roadmap?
Yeah, sure. So I think this is also not exactly true. It's like more, again, for it to be used, to get like all the kind of benefits is designed, like in principle, like in theory, you could have like an integration that puts all the client code into a single file. And then the bundler integration could be very simple because then, it would just concatenate all client-side code, but that's not really efficient. The reason we need a bundler integration is because we've introduced this concept of directives. So there's use client and use server. They don't actually mark client and server components. This is one of the pieces where like the naming is introducing misconceptions. They kind of mark the doors between the worlds. So use client kind of marks, it's kind of like a script tag. It's like the rest of the imports from this point, any code imported from this file is going to get into a bundle. So use client is kind of like an entry point. Like here's where the script tag starts. And then anything imported from that is going to be in the script tag. And then use server is not for components. It's kind of like a door into the server. It's if you actually run a JavaScript server, it's only useful in that case. It's not useful for static generation, but it's where you mark an endpoint. So use server is kind of like, here's server code that's callable from the client. And so if you use something like TRPC that is pretty popular these days, it's a very similar idea. It's just instead of writing fetch post on the client and then like request on post here, I'm going to run this function, you just import the function. And if it has this directive, it means React will give you like an async, a thing you can await, but it will actually post to that endpoint. And it's just a way to call functions. So this is like the kind of features where you do the same things you could do like with PHP and jQuery, right? Like you can send the script tag with a bunch of stuff, and then later you can like call a REST like HTTP post. But really, these two things are represented as imports. So it's kind of like your PHP. It's like if your PHP site could import a jQuery component and render it, and then if your jQuery component could import a PHP endpoint and like post to it. So this kind of integrations require a bundler.
So the question I have about the bundler integration makes sense, right? And these new, use server, use client directives. I like how you kind of put it as like, you can see use client and think of it as like a script tag. It's kind of like a, just a point where the bundler will split off. When I was migrating from the pages directory of Next.js to the app directory, one of the very first errors that kind of pops up is like, oh, you're using like React to use state. That should be a client component, add this directive. So why is the use state, the React client side kind of primitives not sufficient of a heuristic to go off of? Because it seems that like early on when people were moving to the app directory, they basically just searched their code base everywhere they had a use state import or use effect. They would put use client at the top, but that's not right either, is it?
Yeah, I mean, you can do it this way. It's just kind of a painful way to migrate. I think they now have it in the docs that the recommended way to migrate is you just take your entire, pages directory. In the pages directory, the way it was structured is you had this like get server-side props or get static props. So this is like the part of the file that executes on the server only. And then you had this like page component in the same file. So previously you were mixing server and client code in the same file. And so in the app directory, kind of the recommended migration is that you take this page component, you move it to another file. So that is kind of the start of your existing tree. You put use client at the top of just that file. You don't need to edit to any other files. You just put it into your kind of entry point, and then your get server-side props, that is what now becomes a server component. So server components are really kind of like in Next.js, they serve the same function as get server-side props in the old Next.js, as like Astro templates. It's just like this part that executes first. And so you really need use client only in client components that are imported from a server component. It's like the place where things turn into JSON. It's like where if you pass props down, they will become, JSON, get passed over the network, and then they will be revived. So I think that is kind of like how to think about migration, is that I think people think of it as a per file, kind of intuitively. They think, oh, I need to open all files and put use client on the ones that are client. But it's more like you have the entry point into your import tree. So you have your like page component or something like this. You put use client on top of that, and that's actually enough. And then maybe later you kind of pull some things out of it. So like maybe you have some data fetching deep down that you're like, oh, actually, I'll just do this fetch above in the server component, and I'll pass the result as a prop. And so you kind of gradually can pull some things out of it, out of the kind of client part to the top, but you don't need to like add the directives everywhere.
Is there a reason why being tightly integrated with the bundler, is there not an opportunity for bundlers to kind of like skip the directive part? I mean, with the exception of the use server from the client, but like, you render on the server, and the very first time you hit an interactive client component, which we know to have like use state or use effect, like, isn't that the equivalent of you going in and saying use client? So like, is there like an opportunity to basically have engineers and React, authors like do less work and have to think about, I guess, like the paradigm less, and the biggest shift is just going from client centric to just like, starting on the server, and the interactivity is already built into React, and the bundler just needs to be a little smarter.
Yeah, no, this is a great question, and it kind of gets at some of these like kind of philosophical issues where, there are things we've learned, and one of those things is that actually being intentional about where the boundary is valuable. Because like there were attempts to do like something that spans both worlds, like ASP.NET Web Forms, early Meteor, and there were like attempts that try to treat server and client as this thing that's like there is really no boundary, but it's not really the right abstraction, because the boundary exists. It's the network boundary, and so you want to know at which point what exactly are you sending, and where is the point where, I pass some props down, but actually they get turned into JSON, and later they'll get turned back from JSON. And I want to be intentional where that happens, both because that's, you need to be aware of, like sometimes maybe you're sending like a huge object. And if you just did this like a couple of layers of hierarchy above, you could just send just a little bit of information instead of like letting it explode into this object. So it's kind of like, in Astro, again, like there's a separation between Astro templates and client islands. And that is a good separation because it lets you decide like which world do I want to put things in. And in principle, I think what you're asking for is like, well, could the bundler decide if there's like use state in this component and like automatically insert use client there? But then the problem is like not all components actually deal well with their props being sent over the network. So you kind of want to be intentional, like here's where I make the cut, but you also want to be able to move that boundary very easily. So in this case, it's like you just copy and paste it and move it to another file. So it does take a bit of learning to like, it requires building like a little skill that is comparable to the skill you have to learn if you're writing like a PHP plus jQuery app or Astro plus React app. Like the skill is always there. It's about where to make the cut, except you can reuse code between both sides now because they compose, because it's a single programming paradigm.
That's just such an excellent point, because that being able to move the boundary, it's not so much that something like has state in it, is that you can even float it a little bit higher too. So you're in control over where that script tag kind of happens. And I think that, React has always done a good job of like thinking of escape hatches, as part of just out of the box, like, not everything's going to work, as a React component. So we need to be able to escape out to like the rest of the world and be like a good citizen. So knowing that some props aren't going to be serializable or whatever, and being able to basically not get stuck to where you can't even adopt it, but you can just move that boundary. That's really helpful to understand. So that distinction between the two of it, it almost reminds me of like the Webpack 2 days of like doing an async import and that becoming a code split boundary.
Yeah, that is actually how it's. So we had a kind of, and actually going back to Amal's question, because I haven't answered it, but there was a question about like what is the state of support for bundlers, and kind of circling back to that is it's actually very hard to retrofit this into existing bundlers because, again, it's like a conceptual shift of a bundler spanning kind of two applications, except that they can reuse code between them, but it's two separate module graphs. Like for example, if you're like in PHP world, you can't really expect to like access, modules from the jQuery world. Like they're separated by this. When you're inside the matrix, you don't have access to like, the food from, I don't know if you watch the movie, it's like two separate worlds. You can bring stuff from the outer world into the inner one, but you can't, like you need to be diligent about how to cross it. And so the first thing we released, in 2020, when we released the first kind of specifications for the React Server Component RFC, which has changed since then. So we did a few revisions in response to the first framework that adopted was Hydrogen, Shopify Hydrogen. And it was actually like, it ran into a lot of problems that like some of them were known, some of them we just didn't have a solution yet. And so they ended up abandoning it. But it's actually their feedback that led to the directives, because before that it was file name extensions. But we, together with our first kind of spec, we also wrote a toy version of a plugin for Webpack. It's very slow, so like it's not production usable because again it's very hard to kind of retrofit it into a bundler that was not designed for thinking of like server and client as two separate programs that have doors into each other. That is really like the new paradigm here is just you have two separate programs, but they have these doors, and like one kind of door is like render a tag with props, and the other kind of door is like async post callback. So they were not designed for this, but we did write like a super kind of simplified version of the Webpack plugin, and it actually internally used the same mechanism that Webpack uses for dynamic imports. Because what we need is just like, we need to create these chunks for, like each use client we discover is like a potential split entry point. So we just needed to create those files. And it's like a level, it's like ideally, if there's demand for this paradigm and if people really see its benefits, we're kind of like skating, like RSC is very ambitious in that it requires some features and bundlers that don't exist. And the idea is like, we can kind of try to polyfill them with like plugins, which is like what Next is trying to do, but it's super convoluted. But this is also why Vercel is investing into TurboPack. So TurboPack is designed for this like ability to have these like split worlds that talk to each other. And Parcel is also designed for like this being like having this ability to have a combined graph from like two different isolated worlds. So I think like as this paradigm becomes more commonplace, the hope is that the next, like maybe it's the person listening to this podcast, like the next generation of bundler developers will treat it as a first class feature. And like, I don't know, maybe like in 10 years, it'll be a standard, like dynamic import became a standard. That's kind of like where we'd like to, I think, get to eventually. But for now, it's this like, like Webpack introduced require.ensure before dynamic import. It's kind of like similar.
Well, yeah, I mean, so I was going to ask about linting because like I'm very curious to kind of get your thoughts on like if custom linting rules are going to help kind of wrangle that, like use client, use server, kind of all the directives, right? Like, and kind of enforce best practices there. But I feel like now I have a more interesting question, which is around the bundlers. So I don't know. Can you maybe quickly answer my linting question? Then we can move on?
Yeah.
Okay.
Yeah. So for the linting, we want to fail at build as early as possible. So it's not even just like linting. We actually like, if you import, we use this thing called import conditions, which lets you run, like specify that you run in code in like a different environment. So React, when you import React in the server world, in the server RSC environment, useState doesn't exist. It's not even just like it refuses to work. It's like conceptually, it's not even an export. React doesn't export useState in this environment. So it's similar to like how you can't invert jQuery in PHP world. It just doesn't make sense. We want to fail early. So this is like the level of kind of protection we have now, is we just like force you to add this direct, like you can't forget about them because we kind of force you to add them. But one thing that's missing is like type enforcement. So one thing we want to do is, if you mark a component file with use client, we want TypeScript to enforce that all its props must be serializable. So it shouldn't be able to like accept functions and, things you couldn't pass from the server. But you can pass a server reference, like a server action, because it's not really a function. It's like, it's actually an object just specifying how to call it. So I think like types enforcement I think it will help explain the paradigm, because when you see a type error, you're like, oh, I see what's going on here. Like these things have to be, like I'm crossing the network boundary. That's why it's saying that there's like a mistake.
Like listening to you talk about what role the bundler plays and how it's like a completely different paradigm from the way we've been bundling today, because there's kind of two resolution graphs and whatnot. It kind of like, it's making more and more sense to me why, Next was really the first on the scene with kind of like being able to support this, right? They have the infrastructure, they have the engineering power, they have all the things, right? They've got all the pieces in place. But at the same time, like, was it kind of somewhat of an unfair advantage that like they got there first? Like, I don't know. I'm just curious to hear your thoughts.
Yeah. So Next was not the first integration. The first integration was Shopify Hydrogen. Next was experimenting with server components for a while, but it didn't really move to what we've seen like in the Next 13 release until like maybe a year after, when Sebastian left. Sebastian is the person who led most of the design of modern React. So he came up with hooks and with much of the design for server components as well. And so this started in, I think, if I'm not mistaken, 2017, with an internal post that is maybe has a spicy title, What Comes After GraphQL? Not in the sense of, we're not like actually like, Facebook is using GraphQL pretty heavily, obviously doesn't want to actually like replace it. But it's just this idea of like, if we have to write these clients that like download all the data, download all the code, and then apply the code to the data, you might as well like do some of that work on the server. And that's how, like at Facebook, that was a pretty kind of normal thing, because previously Facebook kind of started as a server rendered app with a server component paradigm called XHP. So it didn't really use like MVC like Rails. It was more like React components, except they executed on the server. And so it was kind of like, that was like one of the ideas, like GraphQL, XHP, and Next.js would get server-side props, like all of these ideas kind of combined together. Yeah, so the problem was like, we wanted to deploy server components at Facebook and kind of start, which is also, they're hard to incrementally adopt because you kind of like have to adopt it from the top instead of from the bottom. So like with server components, if you have an existing app, then the kind of the pathway to adoption is not that you like rewrite small parts of that app in server components. It's more like you wrap your entire app and you put the server components layer before them, which maybe just like renders your app. So it doesn't do anything. But then you can like start moving things a little bit into that world, like from the client-centric world. And so at Facebook, this was not unfortunately possible due to technical limitations of how our PHP and JavaScript, like, we were running like a custom JavaScript engine. It was not V8. The way it was communicating with PHP is like very different from how it's usually set up at like most companies in open source. And so we were kind of faced with this choice of, we know how to make this work. Like we have a solution for a bunch of issues that, we've had for a long time. We think we have something novel. We think we have something that's like combines, the best side of kind of client server paradigms like PHP plus jQuery or like Astro plus React, or like it has like, it's kind of, it has this like all characteristics, like things we've learned over the 10 years of like, streaming and like sending less code, but also just full stack components, this ability to write components that are encapsulated and span both worlds. So we have this thing, and we just, we can't keep developing it because like Meta is like, Facebook was kind of stuck because of the custom bundler, custom JavaScript engine, custom setup between the server and, and it was already very optimized. So it was kind of like in the local maxima. And then the team that, I'm not like assigning blame or anything, but it's just like we needed help from the team that maintained the custom, all this bundling infrastructure at Facebook. And that team was actually busy because they were all put on the like end-to-end encryption project for Messenger. And there was nobody who could, drive this kind of big, technical redesign of like how all that data fetching works. And so the choice was like, do we sit on this technology for several more years just because Meta is stuck, or do we go somewhere else to complete it? And so we didn't want to sit on it. And so Sebastian left Meta, and the question was like, where can he complete the vision? The ask there is pretty big. It's like, develop a new generation bundler, bet on this completely unproven technology, and YOLO. So the thing that, with Vercel, Vercel has kind of invested into just, trust in Sebastian's direction. So when Sebastian came to the Next.js team, basically like on the first week, he was like, we're going to rewrite everything because, we need to throw, like, these abstractions don't quite work anymore. And like, we need a new bundler. We need like, all of these things need to be new. And so that is like a very big bet to make for a very successful product. Like Next was, and Next is paying the reputational cost, and like Vercel is paying the reputational cost for, let's just try this completely new thing that's like unproven, and let's prove it out kind of in the fires of shipping to production. And that's usually the process that, if you're like consuming React from outside, that's the kind of process that happened at Facebook. So like, when React was developed, like you didn't see that process because, it, like by the time it was open source, it was already pretty solid. So you didn't see like, the early React. But this is kind of like seeing that process play out in the wild. And I think the biggest thing is just Vercel was able to, allocate a bunch of, many full-time engineers to work. It's like 10 people to work on this full-time for several years for something that's not proven because they believe in Sebastian's vision, essentially. And I think that's, and like, it, like parts of it are still kind of rough, but I think it's getting to a place where it's actually getting really usable and proving itself out.
Yeah, no, that makes sense.
He said it really well, too. He said, for history revisionists, I went to Vercel and changed Next.js. I didn't change React. The React stuff was already there pretty much. And so I think that's like really interesting. So with Next.js being not so much, the first one or like early adopter, but, helping to like refine and dog food it and, and actually put the resources behind it to make it a reality. Is this going to be a competitive, first mover advantage for Next.js that, or will like Remix, are they having to play catch up? Will other bundlers basically this is a very much a React thing, but has to have that buy-in. Is this going to kind of create like a bit of a moat around Next.js because of their investment in it that others might not be able to immediately catch up to?
Yeah, I mean, I think realistically that is the case currently. I think not for technical reasons. So, it's kind of unfortunate in the sense that technically, like the work is layered very carefully so that, all the parts that are not Next.js specific, they're in React. So there's like every feature is developed in a way, like even things that people think are somehow associated with Next.js or Vercel, like they're kind of layered in a way that wherever there is leverage by putting it into React so that like other frameworks can build around the same concepts, or you can make, you can put a component on NPM that would work in any framework that adopts RSC. Like that is kind of the goal of this, why RSC? Why not just call it Next.js? Well, because like we don't think there's, these concepts are actually specific to a framework. It's just the concept of splitting the file between the two worlds, or like not the file, but like splitting the modules between the two worlds. And I think realistically, currently, it's just the team barely has time to document all the user facing stuff. So documenting all the, like what is the, like for example, like for the wire format, we don't document it because we provide the reader and the writer for this format. They're in the React repo. They're not in Next.js repo. So like in principle, anyone can use them, but you just have to, you have to know like which folder they're in and like what the API is. And you can look at the tests, like the tests are also there, but it's just nobody has infinite time when like things are on fire. And right now everything is on fire because people are starting to use it and they run into all the bugs, they run into all the missing features. And, the top priority for the team is obviously just to make sure that this paradigm survives, which means just like making it usable for end users. But I think as like things kind of, we have, yes, like framework authors are kind of poking at playing with it now that there's some kind of knowledge that, we have a group, like we've had a group for a while, internal for framework authors, where they can just ask questions and like we try to reply as fast as possible. But I think really the thing that will take it to, the next level where, people don't feel like there is some kind of like unfair advantage is just there needs to be a bundler that supports this so that it's easier. You take the bundler, you take the React parts of this thing, and you just, you go wild with it. And until that exists, it's just like, it's much harder to experiment because you have to either write a bundler plugin yourself, which requires a lot of specialized knowledge. I don't even know how to do it. So currently it's kind of, you can only do this if you're willing to like invest months into understanding how to make the bundling work. But then, with Parcel adding support that's like close to built-in, or like a plugin that's like really kind of fits into the architecture, with TurboPack hopefully getting stable and hopefully being usable outside Next.js, I really hope they make it like usable as standalone, but keep the support for directives. I think these things will help it kind of propel more into mainstream, because then people will be able to play with it. And if you can just like, just like fire up a node server and just like call this function and see the output, I think that's where people feel like, oh, I understand how this works. I understand where the boundaries are. So I don't feel like this is specific to Next.js. But I think realistically, it's true that just, there is some, proximity to, if you take the burden of trying things out first, then you also like reap the benefits of you do have a solution first.
Yeah, I mean, I think, first of all, I just want to say thank you so much for this incredible backstory and history, Dan, because I think, I think, at least for me anyway, I empathize with kind of Vercel taking the heat, right? And like you said, like they're taking the reputational cost. And Guillermo has been someone who's like always made big bets on the web, right? Like, and he's obviously someone who cares deeply about the web. And so I'm like, wow, like respect for like investing in this, like, and taking this big bet on RSC and like putting literal like cash money behind it, So,
but I mean,
like
I can also see, like, I can see, there is of course, a commercial angle in the sense
of course.
And I think it's sometimes maybe misunderstood as like, I think the angle there is kind of similar to the Apple angle of like vertical integration, but it's also a bit different because it's like all open source. So it's kind of like, I think the idea is, what if you designed the architecture with kind of deployment model in mind? And that is something that, at a place like Facebook, that's obviously how it's going to be. Like you have a whole team of infra engineers, they will think about like, how do we distribute work between like our data centers and our, how do we cache things, at which layers do we cache things, and so on. And then like smaller companies can't really like afford to think about this. And like Sebastian as an architecturally minded person, like cares both about, how do we design it in a way that it doesn't run into the walls that we've seen over these 20 years. We know like PHP without cache and will run into a wall. Like, client side only will run into a wall. GraphQL only will run into a wall. So it's kind of like designed, like, how do you design the paradigm so that it can be like distributed in a good way? And then Vercel is kind of like, we're looking for a paradigm that can be distributed this way because we're actually a solution for, distributed computation. So this kind of fits perfectly. So I think like that is kind of the interest in like, they want a paradigm that's able to take full advantage of the infrastructure they're building. So it makes sense like that they want something that's like designed in mind.
Yeah, of course. I mean, it's also just like from an open source sustainability perspective, like open source is sustainable when you align it to business incentives, quite frankly, like just real talk, So just no hate there at all. There's just so much that we didn't have a chance to get into, y'all. We have been talking for like forever. I'm going to like wrap with just a couple questions. So the name, React Server Components, because this is, we talked a little bit about the community FUD, right? And some of the misconceptions and whatnot. But like, you know, do you feel like if you could do it all over again, would you pick, would you, Dan Abramov, like, right? Like you don't speak on behalf of everyone on the team, but would you, Dan Abramov, call it something other than React Server Components, given the amount of confusion that this has ensued in the community?
I didn't see a better term. I still haven't seen a better term. I think it's one of those cases like in React where we, you know, maybe it is a bit arrogant, but we kind of redefine what the term means. Because, you know, like with rendering, like maybe it's unfortunate, but like we needed a word. And like in React, rendering means just computing, you know, the UI, not like painting it to the screen, but it's just something now people kind of use that word in the React sense. And I think it's just one of those cases where we're staying true to the conceptual meaning of server and client, because it's two programs. One program sends the other program to like potentially another machine. There is potentially like a distance between them. So the boundary has to be, you know, serializable. And yeah, kind of one program serves the other program, but it's just, you know, it doesn't map exactly to the physical concept of like server and client, because, well, like a server can be like a client to another server and so on. Like it's like, we just have to be, you know, like if I were to reintroduce this concept, that maybe kind of talk about what we mean by the server and the client. It's just like, you know, the server is the part that runs first and that returns, you know, the client part that runs second, and they can run. But as we talked earlier, right, like even like 2016, like people already figured out you could take the client program, run it on a Node.js server and to produce initial HTML. So like we've already put the client on the server before. And then with something like Gatsby, like there was like an insight, oh, actually you can run the server itself ahead of time during the build if you know all the requests you want to hit. So we also put the server into the build or like a deployment. So these concepts are already kind of muddied. And from the point of React components, it makes sense. This component kind of serves this other component, so to speak. So I think the name is still right. We just had to explain what we mean by the name.
Yeah. No, that's great. I'm proud of you for sticking with your guns, Dan. That's fantastic. We could have just started a whole new rumor on the show, you know?
Maybe I just don't have the imagination.
Oh.
Like maybe I'm just...
I doubt it. And so Dan, if people are like, all right, well, you know, as you know this better than I do, you know, the circle of people who use React is much larger than the people who use Next.js, right? There's tons of people who use Next, but like the React community is bigger than the Next community. And so, you know, for folks who are like, oh, I mean, where can I get started? Where am I looking? Like, what are official docs that I can be using and leveraging, right? Like the rollout on this has been very unusual, like compared to some of the other releases that we've seen from the React team, right? And so, and of course, there's been big shifts in the team itself, right? So this is like now we have people from outside of Meta that are part of core. You know, and I feel like as a result of that, like there's more work in the certain parts of the sausage are being done in the open or being done in different places. You know? So I'm curious, like, how do folks like actually get started on this at this point? And then also like, is there anything that we could have done or you would have done differently with the rollout of this feature, just given the FUD and confusion that folks seem to have?
Yeah, I think... like in terms of getting started, realistically, I just think Next currently is the most complete kind of implementation of the vision. So if you want to get like an idea of how it was kind of designed to work, at least like by the person who originally designed it, I think that is like a good way to look at it. Again, it's still pretty rough just in terms of, you know, like the developer server is maybe not fast enough. So there are like many paper cuts. But I think that is the place to kind of get the initial impression.
Do you think it's production ready right now, as of today, February 2024?
Production ready is like a very subjective concept, I think. Like Facebook used React in production way before most people would call it production ready. There's definitely pretty large companies using, you know, Next.js app router in production right now. And, you know, both like hobbyist and big companies. but it does have, I think, like, especially like there are some features that are less baked that are like currently being, fixed, but like parallel routes, intercepting routes, there were like a lot of bugs related to those that are being fixed right now. So I think like in a year, I expect it to be a lot more kind of bug free and, like just doing the right thing. I think currently it feels a little bit like a little shaky in some places and maybe like slower than you would like for just developer, like the dev server is a bit slower. So that's something I expect to see with TurboPack fixed. So I think it's ready for production in the sense of you can start building with it. It's not going to change under you like in some significant way, like the concepts are stable. But I think like I think maybe actually the biggest part is just because the conceptual model is new, there aren't really a lot of resources to kind of explain how to think in it, or there aren't really like best practices that, you can just, it's kind of like React in the early days. Like if you would use React in 2014, then I think, yes, you can totally use App Router. If React in 2014 seemed to, kind of raw to you and you would rather like wait to 2016, then I think this is similar. Like maybe you can wait a little bit and then give it a try when there's more resources and more people kind of understand how to use it, and it's easier to find like answers that are correct.
Yeah, that makes sense. And so in terms of like your own risk for it's not even risk. It's like your own appetite for being on the bleeding edge and like your team's capacity to kind of do a lot more learning through maybe reading source code and like experimentation. And
I think like not necessarily source code, but I think it's just, like we've talked about things like use client or use server that are like very misunderstood. And it's just like until there's like a couple of really good blog posts, the same way as like React was pretty misunderstood in 2014. And then like there were some talks, there were some blog posts, there were podcasts like this one, right? And like eventually there's like enough kind of knowledge between people in the ecosystem that they can help each other. I think that's where it needs to get.
Yeah, no, that makes sense. All right, and my last question, this doesn't even have to do with React server components. If you could wave a magic wand for like one thing that you want to be on the web, right? Whether it's a feature or even in a library, like what's one thing that you wish was on the web that isn't there today?
Yeah, I mean, I'm pretty selfish, right? Like I like React, so I'm interested in like React getting better. But I'd really love like a deep first-class support for animations, because this is something you can already do with like libraries like Framework Motion. So it kind of feels like, well, it's, you can use it, it's already there. But like similar to how, server components and kind of resolved a bunch of, like it lets people compose. The biggest thing with React is always, we want to let people compose things. We want people to take different parts written by different people, kind of connect them together and have the result still make sense. Whether, like server component kind of extends it between like client and server. So you can have these like Lego blocks that are spanning both worlds, but you can still treat them as components and compose them. And for animations, like this is something like I'd also like to see where maybe the person writing the currently like with Framework Motion and animation approaches in most other libraries as well, usually like the person writing the component has to be aware that it's animatable. So you kind of have to like express the animation at the leaves. Whereas from kind of React's point of view, like with like people to be able to like write components, and then you should be able to like animate them from above and kind of say like, I'm just changing this state from, like gallery index 1 to gallery index 3. And I also want to kind of show like this like gallery item, the actual like carousel items created by somebody else. Like I want to specify where the current item is placed. And then somehow, you'd have like an API. I think like view transitions API is like a step in the right direction.
Mm-hmm. I was just going to bring that up. I was like, I feel like that's like like the baby, that's kind of getting us there. But yeah. So
we want that, but we want to integrate it with the component model so that it's also very composable, and you can put things together written by different people and like animate them in a way that's doesn't break as you keep doing that and keep kind of expanding. Like there are many like small nuances of like, what if you have multiple animations at the same time? Can like one of them wait for the other, or should they happen like together? what if like the state updates in the middle of the animation? Like, should we kind of hold that state update back until it finishes? So that there's all these like small things that are not really composable if you think about them in isolation, but something like React could actually orchestrate it. And so I'd love to see that maybe in a couple of years.
That is so cool. And also today I learned Dan Abramov is like an animation stork. Did yeah, clearly, very passionate about animations. Well, Dan, again, it was this was just such a like mind-blowingly deep and dense and educational podcast discussion. So really want to thank you and Eric for joining us today. For folks who are listening, it's probably going to take a few listens to kind of get all the gems that Dan and Eric were sharing, but worth a few listens. If you've stuck with us this long, thank you. And yeah, so just, you know, as hopefully this part of the ecosystem continues to mature, we hope to be able to kind of have more discussions on this and kind of, you know, continue talking about it on the show. And in the meantime, we'll put links to a bunch of stuff that Dan has shared with us to kind of, so you can take a look at some really good blog posts and some good write-ups on this topic. And yeah, and feel free to use the discussions area on our website for any questions or comments. And yeah, thank you so much again, Dan. It's been a pleasure.
Yeah, thank you so much for hosting and for inviting me. And also, I apologize if I know that some explanations were kind of long-winded, and I also don't know which of them really work. So I think I would like appreciate if the listeners or the readers, you know, if you carried something away from this, like write about it in your own language, because I feel like the underlying concepts are kind of at the fundamental level, they are simple, but then there are a lot of like historical baggage and kind of how they combine together that is more difficult. And so I'd appreciate if people could help distill them down like in a better way than I could do here.
Yeah, no, that's like such a great call out. All right, Dan. So once again, another one in the bucket this week, and hope to catch you all next week where we'll be talking about something delightful as well, I'm sure. All right, everyone. Cheers. Bye-bye.
That is JS Party for this week. Thanks for hanging with us. Subscribe now if you haven't yet. Head to jsparty.fm for all the ways. And don't forget to check out our fresh changelog beats. The new Dance Party album is on Spotify, Apple Music, and the rest. There's a link in the show notes for you. Thanks once again to our partners at Fly.io, to our Beat Freak in residence, Breakmaster Cylinder, and to you for listening. We appreciate you spending time with us each week. Next up on the pod, we're talking Angular again, this time with a focus on the future. Keep your podcast app tuned right here. We'll have that episode ready for your ear holes next week.